derivative process, you need to do what first? Rewrite. Now this one is to the 2/3 power, so I'm going to have that rewrite step. So it's really going to be x squared minus 1. It's already got a 2 there. It's not to the 1/3 power. It's to the 2/3 power. Remember, the numerator is the power, the denominator is the root. So the last one, the reason it was 1/3 power there is because there wasn't an exponent on the inside.
So if I took that whole thing to the 1/3 power, that's already
Yeah,
wrong.
it's going to be wrong. Well, you might, if you didn't count for the 2, it will be.
But I need to count for the 2.
Okay, so what's the inside function here if we're looking at this? X squared minus 1. What's the outside function? X to the 2/3. So if we're looking at this, is it a f of g of x or a g of f of x? Based on what I wrote. It'd be a g of f of x. So we're going to do the derivative of the outside first, evaluate it at the inside in terms of the inside. So the inside, we don't mess with it. We just say, okay, that layer of the onion has not even been touched yet. Okay? Times the derivative of the inside. And then once you get to the inside, you can ditch the outside. All right, so with that said, who wants to give it a shot here? David, go ahead. So what's the first part you would do? Yeah, bring the 2/3 down. What are you going to do when you bring, you're going to 2/3 times, what about the inside?
It just remains the same.
Remains the same, evaluate it at the inside to the what power? It becomes a negative 1/3. Don't forget to subtract 1 from the exponent. Okay, that's going to be a common mistake. People make that one often. Times the derivative, because remember we got multiple layers, so multiply. 2x. That's slick. Okay, chain rule's awesome once you get the hang of it. Okay, now we got 4x. We can do 2x times 2x. This will go where? To the bottom with the 3, so we got x squared minus 1 to the 1/3 power on bottom, and there's that one with the chain rule. Okay, look at example 4 with the chain rule, and then we're going to go to the hard one. And that's the one I'm going to finish with today. And it's really, it's the bone.
This is trying to push you to do product.
It's trying, like here, let me look at this. You could try it. Here's the problem with this one. Okay, let me talk about this. Rewrite it for me. Do you really want to do quotient rule? Not unless you have to. Get out of it if you can. And the reason you want to get out of quotient rule here is because there's a what on top? A constant. You should never have to do quotient rule if there's a constant in the numerator or denominator. If there's a constant on the denominator, it's super simple. Like if this would have been 2t minus 3 to the 2nd power over negative 7, you would have just treated that as a negative 1/7, and you would have done constant multiple rule. And then it would have just been 2 times negative 1/7 times 2t minus 3 to the 1st, and then times the derivative of the inside, which would just be a 2. Okay, or you could have just foiled it out, and did simple power rule completely. Now this one, you can't do that. Now let me tell you why. You ready? Because people are going to ask why you can't do that. When I move this one to the top, pay attention here. Negative 7 times 2t minus 3. This is going to help me avoid quotient rule. But you can't avoid chain rule here. There's some people that want to say, why can't I multiply the 2t minus 3 out so that I can just do simple power rule? It's how you doing that negative exponent. The only way to get rid of the negative exponent is eventually move it back where? So now you're forced right back into quotient rule. You can't deal with the negative exponent like that. It's not like a positive exponent where you can FOIL it out. Okay? So therefore, that means this rewrite step, that's it. You don't have an option. You are forced to do chain rule. You can't get out of chain rule here. The only way you can get out of chain rule is go back to the quotient rule. But if you go back to quotient rule, you're still going to have to chain it. Unless you FOIL it out. But you can't FOIL it out with the negative exponent. Look at me. Can you FOIL with the negative exponent? No, you'd have to move it to the basement to FOIL it. That's why you got to use chain rule if you choose to move it to the top. So this will be g prime of t then is what?
Negative 14, sorry.
14 times 2t minus 3 to the what? Negative 3 times 2. Don't forget the 2. Final answer then will be 28 over 2t minus 3 to the 3rd. And here's the thing, guys. I don't think you want to avoid chain rule. you're going to start to look for ways you can use the chain rule because you're going to like it so much. Because it is faster. Chain rule does make things a lot quicker. But once you learn chain rule, it really opens the door up to, hey, we can just learn as many rules as we want. And we always go back to, hey, if you know how to use chain rule, it doesn't matter how many new rules you got. You're always going to use the new rules, probably the chain rule anyway. The only time you ever really do anything different is if you have to do a product or quotient rule problem that you can't get out of. That's pretty much it. You got chain rule, product, and quotient rule. You can introduce all the new rules you want. The rest of it's just memorization. You'll see how that works tomorrow. Now, example 5. Here we go. The big one. Get ready to have lots of room. This is the last problem we're doing today. Then it will take us to the end of the hour. All right. What makes this problem interesting is everybody automatically is going to say, yes, there's a rewrite step here. What is the rewrite step? Yeah, get rid of square roots always. So we're going to have f of x is going to be equal to x squared times 1 minus x squared to the 1/2. And then what you're hoping to do always is, can I rewrite the problem pretty quick without a lot of work? Am I able to rewrite the problem fairly quick so that I can get rid of product or quotient rule? There are times where you can't get rid of product or quotient rule. Is this one of these times? Yeah, because how do you do the 1/2 power? How are you expanding that? You're not unless you rewrite it back as a what? Square root.
So you
Here's
just
the
can't take
problem.
1/2.
Here's the problem. There are no derivative rules for square roots. The only derivative rule we have for a square root is rewriting it back as a power. That's the only way we're able to do derivatives of
How
square
come you
roots.
can't take like 1/2 times x squared?
Can't, because you gotta somehow FOIL this. How do you FOIL a 1/2 power? You taking half of it? That's not what it means. It means a square root. So you can't do anything, guys, with negative exponents and exponents that are fractions. You will not be able to expand them because they're involving roots or they're involving things that need to be moved to the denominator. That's why you can't expand them. The only ones you can expand are integer positive exponents. So with that said, you don't have a choice. You got product rule here. Does everybody see it? And how do you know it's product rule? Because I'm multiplying two functions. Now, here's the interesting thing. I'm going to do some labels. And you're probably going to want to do this. If this one's u and this one's v, so this is u and this is v, all of this, when you get into the product rule, let's project a little bit here. You do, what is the product rule? Tell me what it is.
The derivative.
Derivative of the first
Times
the second plus derivative of the second times first. Now project a little bit. Derivative of the first is not going to be a problem, is it?
No.
Times the second is not going to be a problem. But then when you go plus the derivative of the second, what are you now going to be forced to use? Chain rule within the product
So
rule.
would it be like?
Well, hold on, let's get to it. It's going to get messy. And it's going to bring back something that we did on the Algebra Gateway test that you love doing, of factoring out least power.
The gateways.
Here we go. The reason I did them. Here we go. So we're going to do the chain product rule. So we're going to go f prime of x. All right, derivative of the first 2x. And I'll label it so you can see it. So that would be u prime times the what? Second. 1 minus x squared to the what? 1/2. That would be your v. Keep up with it. Did you do it? Did I do the derivative first? Did I go times the second? Now, what's the product rule say to do next? Add, but it says to add first. So add.
1/2.
All right, now, when we get to that second part, v, go ahead, Mason. This right here is it's a function inside of a function. The inside function is 1 minus x squared. The outside function is 1/2. So he's using chain rule here. So go for it.
Would be 1/2 times 1 minus x squared times -2x.
Be careful. See, that's the problem. You forget exponents.
Oh man.
If people forget exponents, I just set it up there. Times, be careful. Negative 2x. Now let's look at that. All of that right there by itself is just v prime.
Plus
No, not plus.
times x squared.
Times x squared. And there's your u. So look at that. Let me see this. Just pause for a minute. See, when I got to v, did you recognize that it needs chain rule? Does everybody recognize why it needs chain rule? There's an inside part. There's two layers to the onion. There's the 1/2 power on the outside. You could call that f of x equals x to the 1/2. And then there's the inside. You could call that g of x is equal to 1 minus x squared. So when I did this, it was starting with the outside part, the 1/2, 1/2, expressed in terms of the inside to the negative 1/2. Don't forget to subtract 1. Then it's times, because chain rules always multiply. It's nothing ever. You don't have to worry about anything but multiply there. Multiple layers. And then times the derivative of the inside is just derivative of a constant 0, derivative of negative x squared is just negative 2x. That was just v prime. Don't forget, times what? The first function. You know how many people forget that? They get so wrapped up in knowing the chain rule, it's so easy just to leave off that last part. That's why if you create labels, it'll probably be a little bit easier. Now, here's where it gets crazy. Okay? I'm going to clean this up just a little bit because it'll make it easier for you guys. Okay? This first part, u prime times v, really can't do anything to it. I'm just going to kind of drop some parentheses off. I don't really need all these parentheses. Sometimes it makes it more complicated. This next part, I can do some stuff. It's all multiplied together, so tell me what I can do. First of all, make it a negative. Why is it x cubed? I do agree.
Because you divide by 2.
The 2's cancel.
And then you add by
And then x times x squared is x cubed. Does everybody see where we got negative x cubed from? Now there's one more part to it.
1 minus x squared.
Is that good? Stop there. Let's let it soak in a second. Does everybody see it? Because this next part you really got to be focused for. Because this has been the easy part so far. Alright, let's review what we did. We rewrote the problem, then we went derivative of the first times the second, plus derivative of the second times the first, then we cleaned it up a little bit. Couldn't do much here. Here, since this is all multiplied together, we can get the 1/2 to cancel the 2, the positive times the negative is a negative, x times x squared is x cubed. I don't know what else to tell you because that's just algebra. Alright, now at this point, this involves something we did a while back. To simplify this, there's 2 ways you can go about this. A lot of people say, well, I want to get rid of the negative exponents. I'm going to move it to the basement. Do you realize if you move that to the basement right now, you're going to have to find a common denominator to get this stuff together? Have fun getting a common denominator with the square root. Not saying it can't be done, it's just not fun. So are you ready? Apparently I am. Okay, we are going to do something we did a while back. You ready? We're going to factor it. Anybody tell me, looking at this and this, how it factors? That's something to do with it. First of all, let's start with the 2x and x cubed. That's the easy part.
Just pull out an
X, pull out an x. Okay, got you there. What else can we pull out? What else do these 2 things have in common?
1 minus x.
1 minus x squared. How much of that 1 minus x squared do they have in common is the key.
No, not half. They have a negative 1/2.
The smallest exponent always. You always take, remember factoring out a least power. You always, remember in algebra class, x to the 3rd plus x squared plus x to the 5th. How much did you factor out? You always factored out the one with the smallest exponent. It's no different than 9th grade. And then you just divide it. So I'm going to take, yes, they got a 1 minus x squared in common, but I'm going to take the one that has the smallest exponent. And then what I'm going to have left is a bunch of stuff.
So then what does that 1/2, the positive
So-
1/2 power equal?
Okay, here's what you do. You take that GCF, the greatest common factor, and you divide each part by it. So we're going to take this first part and divide it by this. What's 2x divided by x?
2.
2. Now, be careful here. 1 minus x squared to the 1/2 divided by 1 minus squared to the negative 1/2. If you divide these 2 things, what do you do with the exponents?
You subtract them, so you get
1 minus x squared to the first.
That's it, to the first. How did he get to the first? It's 1/2 minus a negative 1/2. What's 1/2 minus a negative 1/2? It's really 1/2 plus 1/2. When you subtract a negative 1/2, you're really adding 1/2. Or think of it as, hey, if I'm taking this divided by this, yes, the x's cancel, we're left with the 2. This kind of moves to the top with it. And then you'd really just be adding the exponents. Now we go to the next part. This divided by this now.
which is x squared.
X squared. And what happens to this part?
Cancels all.
They just cancel. That part's beautiful.
Is that all we can do to
No, we're almost done now. Now, you can simplify in this big parentheses, and you can move this one where?
To the bottom.
So this x, this could be left out front, so it'll be equals x times whatever this simplifies to. Let's do it. We can do this in our head. 2 minus 2x squared minus x squared. What will that be? 2
minus x squared.
minus 3x squared.
This is negative.
Okay, good with that?
Yep.
All over this thing, pop to the bottom. 1 minus x squared to the what? There you go, that's the answer.
Here it is.
But look, it's really not that much work. It's just heavy algebra here in the middle. Really heavy. Intense. So tonight, what I want you to do, I want you to go back and do, listen, I want you to go back and do the chain rule practice. Check the answer keys from the other stuff, the Anton, the Tana. I'm going to be light a little bit tonight. I'm going to go back, instead of doing, you know, you went 7 through 21 odd, 8 through 30 even, 8 through 20 even, 22 even will just be simple chain rule stuff. 24, 26, 28, and 30 is that,
Nice.
like we just did.
So are you?
Expound.
Is there any hint that that would be like?
Here's how you know you do it. Let me say this. You know you're going to do this when you have chain rules in the product or quotient rule. If you have a product or quotient and you do the chain rule in it, you always have to factor all these powers. Every time. Every time. Doesn't matter.